Hello again. We'll continue from where we left off. So the last thing we did was getting confused about the why the scheduler doesn't work as I expected it to work. But what I ended up doing was I kind of switched this to the total CPU count equal to 1/4 of total CPU. So basically the defaults, and in defaults it kind of worked. I'm still a little troubled about it. I haven't had a look in between the videos, but what happened is now this is cached out. So let's have a look. What we cached out is obviously this doesn't resolve like that because it has the expression. For this to resolve, because this is the scene restarted, so we can just do like cook selected, save, continue. We'll find the files, as you can see, because they already exist. And if I click here, then the wedge cluster ID will be generated. It's going to switch. So if I select here, then I can, let's say, copy this path. So let's put this now in because it's what we're going to render, right? So let's create a little render node here for testing. So we can create another primary. Let's put another one here called rendering. Render nodes. And we're gonna split this to environment, primary environment, geo, environment, secondaries, buildings, geo, building, secondaries. So we can again split that internally here. So this is the environment. And then actually let's do something like this. And two more inside. Oops. And this goes in here. This is environment geo and environment secondaries, like particles and volumes. Secondaries. Okay, so let's put a geo here. Let's call it land animated and land RBD, I guess. You know, this is up to you again. I'm not really sticking up to my original plan. I think this could be a bit nicer. Usually when I redo my things, this I guess it's like a general rule anyway, everybody does it better the second time. And it's like when I finish a show and go back to do like a post-mortem, and like I'm usually surprised like why would I ever do it like this way but not that way. So I guess it's like a quite a common thing to regret your workflows once the job is finished. So we have a land animated. So these are render nodes, and I'll make the render nodes again black or purple. Let's go black. Let's do did we cache that out? We didn't, but we will for Redshift later on. This is what we are rendering. Animated ground better. Did we create a rest attribute? So this is one thing probably we need to do actually. Looks like we skipped it. Any render object should have a rest attribute, so we can stick textures to it. It's packed here, and we should have probably done it here. Well, it doesn't matter. We can. At this point, it's not simulated, so let's do it. Let's do an unpack. We should still have the names here. We have the names, and let's create a rest position. Unless we have one here, we have some attributes here from the height field. So we're going to use those in shading if needed, but we don't have a rest attribute, so we can't really stick textures to it. Like if we want to use a triplanar projection, etc. Now we have a rest attribute here. Do we have mask? We don't have mask, it's 0, so let's clean that up. Actually, we don't want to do it, well, we can do that after. Well, actually, let's not do that after. Let's do it now. So let's remove what we don't need. Bedrock. Let's put a color soap. I mean, I didn't use them really in the final render. Just was just a simple shader, but why not? And like I said, we can do it a bit better. But at least I should show you the ways anyway. So there's a bedrock. So the bedrock goes from -4, -37 to 50, -37 to 50. It's like a height field almost itself. Yeah, I don't know if this will come handy. Let's check the debris. The things wash off from 0. Let's say from 0 to 3. Okay, this might come handy for shading. There is debris. There's also height and mask and sediment. Okay, I'm gonna remove. Not this. I need that for packing back. So let's remove bedrock. Let's remove height. We can always bring them back anyway if we're stuck. But for now, let's just remove everything. Actually, let's remove everything but rest and UV. Everything except rest and UV. I don't want anything from here. In primitives, we keep the name because we're gonna pack it back. Let's get rid of this guy as well, and let's pack it back. Our groups should have stayed intact. No, wait, kill. Pack by name. It's trying to really be something. Let's let it cook. Remesh 3. Oh, it's doing the right side because we changed it. So there's a flag somewhere. I guess it's trying. Oh yes, because I can see the edge of the thing. It's probably templated somewhere, so it's trying to calculate it. Let's let it cook. It's almost finished. Okay. This is now packed. Probably yes. Let's pass the name as well up. So this should be. I'm gonna kill that template. There's a template somewhere. Let's turn this off. Come on. Okay. I think this should still work. The group should not be broken. Yes, they're not. Okay. So let's now continue. This needs to go. We should probably cache it out here. I mean, it's cleaner if I don't bring it in here and cache it. So it's better if I cache this inside. We can definitely, let's do that actually. Let's do a file cache. No, we're gonna read this back from here. So I'm gonna put a null. Out animated land. And we're going to bring this back to a file swap. So I can cache it like this, but you know, we have PDG, so why not? Did I cache this somewhere in a nicer way? This time it's not animated though. So let's go like this. And I wonder if we really need this inside. We could probably optimize this so much better. I'm not gonna cache this now. We'll do it after. Okay, because we have so many inside faces that we probably don't need. We should probably get to think of it, because these parts we really don't need anything inside, so we can really optimize these areas. We really don't need that kind of geometry. In fact, I don't even need the side geo. I just need what's visible from this angle. Okay, we will get back to that later. So now let's just go easy and let's bring in the object merge this guy here. Let's say, where's my parameters sheet? It's here. Let's pin this Okay, terrain, you go there, make it in case there's a transform. There isn't, but it's fine. And now the land RBD, so object merge. Let's go back to terrain. It's gonna be what we did last time. Let's call it null. This will be out land RBD, but because we wedged it, so we need to do something here. Oh, it's trying to simulate. We're not gonna simulate this anymore. Instead, we're gonna read this back from here, from a file merge. Okay. Our path was, let's go to our simulations, and this is our path. Let's copy the path. We did how many? 0, 1, 2, 3, 4. That's 5 pages. So let's go back in here. Let's put this down. So the file merge allows you to, it runs a loop inside. It allows you to load files from using a pattern. So our pattern is all same except this guy is changing. So here I can say $slice because my merge variable is slice, and then here I can say $f4, right? And if I do that, and if I visualize this now, I'm gonna hide everything else, remove the is it stuck? Oh no, it's visibility zone. Okay. It's a ghost. And now we said we have like 0 to 4, so it's like 0 to 4 should load the rest. And now if I hide everything else, I have my simulation cached out as points only, because my ultimately final render is not this, it's Redshift. So, and I want to be able to learn how to utilize farm. So we're gonna learn how to bake these into Redshift proxies. So, but for now, this doesn't make much sense. However, there's one thing that I'd like to mention. So if we now have a look at our file size, which is this folder, and it's 2510 frames totaling 1 GB. So if this was the geo, this will be probably like 100 gigs. So we saved a lot. Okay, so what happens though is that sometimes these things don't work really well, and when you have too heavy, it kind of crashes down. But this is one section, and I can even scrub it because it's actually just loading the heavy part once, and then it's just loading back the points, right? So it's so much lighter to load back points from hard disk and to put the weight on the CPU to do the transformation. This becomes much more responsive. Okay, so if I had a camera something like that, I guess this is fairly similar to what I was doing. Obviously there's a lot of room to improve the quality here, but we are trying to make, we're trying to, like, I'm trying to teach here the most of the time the principle on how to approach to a tutorial, to a project. So obviously if this was for a future movie, we would be generating a bit more based on the camera, of course, like a bit more detailed edges and broken up shapes. With the power of a farm, of course, this becomes very feasible. So now what I need is, however, to get the entire thing, right? So how do I do that? We need to bring in the entire part before we split it with our wedge system, which is maybe this one here. Or where did we do the splitting? Is done here. So it's using the same names. Maybe this will work. Let's try. Yeah, this seems to be working. All right, cool. So now our first simulation is complete. Our ground is opening and it's crashing down. Cool. And then we're gonna put the buildings on the edges and they're going to fall inside. Now, but they made the direct connection. I don't like to work like that. So let's bring in the hero pieces into an object merge. So no streams are crossing. Ooh, I made a joke. All right. And so this is the one that goes into the render there. All right. So our landscape, our geo that falls forever down. I guess we don't really need to worry about that for now. We can remove them always with a clip. Or actually, there's a, because we're using the points, there's a better way to do it now. We can, I think, clip this guy here, and then say remove by, I guess, let's go here, origin go down, minus 50, minus 75, and if I do that, it should only put the points. No, it's keeping some of the pieces in their places because it couldn't find them. Well, it's not a big deal because we can actually say, yeah, there are ways to do it. I can always go to the last frame and then say here, group all these guys and then remove them from the scene, but they could be coming up from the top as well. So okay, we'll optimize again later. Let's not get away too far away from the task itself, but at this moment we have a land that opens up and falls down. This is the part that we didn't simulate, right? So let me actually kind of fix that because we had a clip. So I guess we need to plug in the clip from there here. This was our clip, so I guess this is the better, yes, option. So if I look here, it should remove the centerpiece. Yes. Let's go back. Okay, now let's rewind back a little bit, and because the clip was after the wedging, so I guess we just need to do something like this. Then bring in the terrain. Let's reference copy this guy and plug it in under here, and that should do the trick. Almost. Yeah, that should do. Oh, I selected something and I'm doing an edit. Let's not do that. I'm going to save now. Okay. What I can do is actually, because we kind of start building the structure now, I'm going to bring in cameras from the other scene. Which we can put them in the layout, I guess. So these were my cameras. Okay, and since we're roughly sticking to our we were roughly sticking to what I did in in my promotion scene, the camera should work. So if I look at the here, yeah, it's kind of like the same. So it starts, I had some offsets, frame offsets, we'll get there, but if I scrub forward, the land will open and pieces will fall. All right, we're getting there. Now I guess we can move on to our little trees. I think that's the next thing we can use. So in order to create some trees, we're gonna now create a environment that will be instances. So actually maybe we should create another one here called environment instance. Let's put a geo env instance. Okay, let's go back into our terrain. Let's go and put null under here, somewhere here, I guess. Let's go here. I could have scattered this on the, actually I could have done that. I don't know why I did that. This should be faster, to be honest. Alright, let's put the flag on. Let's load in our environment. Is this geo? Is still height field? We can do the height field here. Conversion, height field conversion. Oh, I have that actually here. This guy. Let's use this one. Okay. So what I did, I created like this noise. So I put in a warp. Okay. And just a turbulent noise to break up the scatter a bit more random. My values were 0.1, 0.01, sorry. Like this. 0.8994. If we, and then I named that out as density, bind export density, and to visualize, we can do that, and this is going to be the 3 distribution. And after that, I'm going to disconnect that. I'm going to put a scatter node. They have now, they put these ones. I haven't played with those as much, which I probably should have, because it's kind of like a really smart way to scatter things, and I admit I didn't use it. It's, I mean, we're not gonna do something different. It's just that we kind of do something similar to this, just a lot more simple. But again, it's in your hands to kind of like adapt and then make it even better. So 10,000 points. I have relaxed iterations by 1, scaled by 20, and max relax is 19. And I'm using the density. Okay, and if I think it's just that it pushes the points a bit away from each other, so some trees don't overlap. Okay, I'm just gonna name this group as trees. Then I'm going to create a little attribute randomize to randomize the scale. So it's p scale in this case, p scale. Again, the land itself, as you may already seen, it's not ultra realistic. So, but that's not the point. Minimum value 0.7. So now we have like this point attribute that says my minimum particle scale value is 3. How is it 3? It's supposed to be 1 because the scale by 2. So it's these minimum numbers and maximum numbers times 2. Anyway, then I have another. So let's call this one. Let's give it a name. Let's say 3 scatter noise. Okay, I have another point warp here that I ultimately wanted to have a few big trees. So to do that, I built another warp, and let's say this would be then size distribution, distribution, distribution. Is it written like this? Let me just Google that. I think it's correct though. Distribution. Yes, it's correct. Okay. Now let's go inside. So what I'm doing is, actually, in order to see the result, let's like copy boxes to these guys, like fake trees for now. Copy to points. Let's do a box. And let's say this box is 3 meters high and 1 meter wide, 1 meter, like just like a real tree. Let's require target points to copy. These are the points. So if I do that, it's just going to be all the boxes now, right? So let's dive inside the distribution. Let's create a random value based on point number, because that doesn't change. So the random value won't change. Let's create a ramp. This is going to be spline. Then I want to well, actually I put a min 0.5. We don't need to, because we can just move the little guy to 0.5, but we are going to need a multiplier ultimately. So let's put a multiply ramp, and then let's promote this, and then let's call it p scale multiplier. Okay, and this is now going to be our well, basically apparently I broke my completely overwritten my p scale here, so let me just ditch this one actually, because it makes no difference. All right, so now, because by default when you do the spline it's kind of like zero size, so if I drag this guy up, you'll see the box is getting bigger. Sorry, let's put this back in. P scale multiplier is with 1, but everything is 0. So if I do that, we'll start seeing some stuff getting bigger. And so I put this on pause. Last thing we were doing was scattering the trees. So, and then we wanted to get like some really small ones, some really big ones. So my current values is multiplies at 4. So like these are now the trees scattered, but we want something along this compressed edge. Let me put this down. So we can put this to spine. So something like this. Just playing it around. Then I want to in here I want to randomize the orientation. So let's get rid of this one. Attribute randomize. I can put an orient here, and orient is not a vector, it's a Cartesian. So my values are uniform continuous, and I'm just randomizing them 0.02, 0.02. So it kind of like gives them a orientation as opposed to everything being aligned. I think we can, this one's kind of like a little bit off, this one as well, and this one just on y-axis. So this is pretty much okay. Now what I'm doing is I was going to simulate these trees, but then I guess I decided not to. Well, then because these are at the moment static, right? So we need to do a point form. These points which are these guys with our moving. I guess we can use this one, it's going to be faster. Oh, but we need to have the clusters, I think, removed because we don't have the center part, which we have to split so we can stick those trees on top of the falling RBD parts that we did at the bottom here, which we're gonna do that now. Okay, so let's see how we did that. It was somewhere here, right? Because we need to deform those with the moving pieces. We need to do that in 2 parts. So how do I get these trees in this section? I have actually, now I think of it, we can probably do something like this. We can scatter on the first frame. It's a bit more flow dependent. I think it might work better. Let's bring this guy here and let's bring this guy here. And we're gonna do attribute interpolate, attribute interpolate. So the required destination geometry is my point cloud, and attributes to translate is, so this comes here. So let's disconnect this. Let's move the box here. So what I'm doing now is, if I need to explain it a bit better, just making a little space, because we have our animate ground. Oh, but we don't have the, we can't just scale. Yeah, actually we can. I should have that. Let me just blast. See, because I preserved groups, I believe, after unpacking. Let's try it. I have some groups. Let's see. So this is my everything but surface, right? So if I do that, yeah, this is everything but surface. So I think I can do that actually. That should work. It's kind of slow. I need this to be faster. I will go back to what I was doing and I'll do the point deform from the not heavy version, and point deform over here should go faster. So this one is not supposed to move, so it's time dependent. Now I put a time shift and I say rest point lattice. So this can be any frame here on the moving geo. So, but we're gonna go our start frame. So it's gonna be here, and the last one is here. So now this should move all the points except the ones in the center are going to be kind of lost. Actually, it doesn't care about those ones, I guess. All right, cool. So these are our trees that we are not simulating. They're just going to be following the ground, but we're not going to simulate the ones in the center as well. Do they just get snapped on the edge? They do. They get snapped randomly. That's fine. And then we can probably do something like, how do I get those little ones? Okay, let me pause the video and I'll find a bit more of a smarter instead of burning seconds. Okay, I just had a revelation. I think because this is consistent topo, but we have our point cloud for the simulations. Let's try with the point. I don't think I've tried that before, but it should work. Why not? If it doesn't, we can always bring in the geo regardless. So because we have cached out the point cache for Rome, this guy, right? So these are all points that are in the here. Okay, and we can do that and that, and that's all falling down, not like how I imagine that will be, because this is falling a bit nicer. Let me think. Is it because the point count is changing? No. Do we not have this here? Yes, we do. radius. Does it need a better estimation? No, these are too much. Okay, what if I bring in the geo then? It's primitive. Okay, well, let's try that one then. In that case, we are going to bring the... These are still packed. This might slow us down a little bit. We'll give it a go anyway. So this is going to be packed. Obviously, that's not going to be happy with that because it's no different than actually... that looks right. Let me just double check. Okay, if I kinda... Okay, I would like to see this being played, so I'm just going to do a flip book before moving forward to see that it's actually working. So let's set it up here. The flip book. I'll pause the video, come back in a few minutes. Okay, so I think that because when they're packed, we are not getting the rotation as well from the surface. So I think this is kind of like working better. We're gonna play with the scaling and everything after, but for now let's leave it as it is, and we will eventually need to cache these out because right now it's like really slow, but we don't want that. So let's also do maybe move these guys to the left a little bit, and I'm gonna object merge the animated ground proxy so we don't make it a bit more busier than it should be. Okay, let's bring this in here. Okay, so this, let's move a bit to the right. This is basically now out trees. So obviously if you want more, we're gonna replace the boxes with trees. If we want more, we're just gonna get more numbers here. 10,000 is not maybe enough. Let's go 50,000 trees, and it should give us a bit more points. Oh, and yeah, that should be alright. Just gonna put this on auto, and we got more trees. Let it cook. Okay, so that's a lot of trees now. Maybe our smallest value is too small, so let's what we can do is that we can do this. We should probably do this all after here, so we can play with the size and orientation much faster. Otherwise it has to cook the point deform, which is like the slowest operator in this curve. But let me actually show how that is visible and how it is important actually, because I see this quite often. So we can do something like this. So what I'm going to change here every now and then is maybe the size and the randomize for the attributes, right? So this is the most expensive operator. So how do I know that? I have this performance monitor. I can edit back from new paint new paint type. It's right here. Sorry. And then I can go like because it's not time dependent here, so it has zero impact once it's cooked, so you can scrub. But this guy is not the same thing. So if I turn on the display flag here, actually let's put it here, and I will record now, and I'm gonna step a few frames. I'll let it cook until it's over, and I advise a lot of people, most of you, to kind of understand how this works. So now I look at it, I say, okay, unpack 4 is costing me the most amount of time, and then the next thing is 0.4. So I can't really, and then it gets colored. I can't really do anything about this because this has to be unpacked. But I can do something here, because now if I change any of these settings, it's coming first. It will, every time I change, it's going to add like 2 seconds to my work, but I can shave that off. by taking this and moving it under here. So now I am able to change the size distribution without getting point deformed cooked again. So that's kind of like useful. With this applies everywhere. You can use this feature. Like it's like almost, if you have like a very live network in anywhere, you can just go flag and then go a few frames, then get, oh okay, maybe I can move this here, maybe I can move it there, so things will get a little faster. So anyway, obviously we want to cache that out as well. So let's put a file to read it back. Actually, we're not going to render it from here, so we don't really need to read it here. We're going to render it from our environment instances, which is environment instance forest. Right, so let's dive inside now here. So we're going to put a file here, and it's going to be instancing forest instance points. Okay, so we will cache it in here, but everything is cached in here. So this is the change land for RBD. Let's put another, no, this is not a wedge. Let's put another rope geometry. So this is a dependency of this, so it will go under, because without RBD land we can't cook the falling down simulations. So let's do something like this. Bake forest points, bake forest PTC, or just forest PTC actually, or PTC RBD land instance forest. Let's call it that instance forest. So the first one will be defining what we're doing. The second one is the name. I think that's a bit better like that. Let's pin this here. Go to our terrain. This is what we want, so drag and drop this guy here. We want the full frame range obviously, and we want to stick to our naming convention, so let's load that back inside here. No, let's do it from what we were recording in the rope geometry output. So let's get that guy, but this time we don't have a wedge. So it's going to be just like this. Okay. And when you leave it as it is, it just launches too many of them. I think this is what we want anyway. Well, also it depends on your RAM and everything. This is like, we can change the different numbers as I showed it before. And then there's the memory users as well. So let's bake this out and then we'll come back to the lesson.